Hello. Again, you are welcome to today's class. This is Biostatistics, and we are continuing with our lesson topic 4, Study Design and Sampling in Public Health. Lesson topic 4, Study Design and Sampling in Public Health. My name is Dr. Henry Aisagboyin, and let's get down to it, and I promise you, you are going to enjoy today's class. Now, we'll be looking at the study design and sampling. Study design and sampling. Now remember, if you look at this topic, it simply means when a research is to be done, there is what we call study design. That is, with what method do you want to carry out this study? All researches cannot be done in the same manner and pattern. They have different design to be able to achieve the best possible results that will be a proper representative of that community or that population, so that when decision is reached, it will be seen to purely impact the entire population without segregating any aspect. And so you need the proper study design. And indeed, to get a proper study design, it will affect your sampling technique. So, what is sampling? Study design: how, when, how, why, and what to do. Now, what sampling do you need? Which set of people will you take? How will you get this set of people to ask them questions, to make them fill your questionnaire, to get information from them? You will need this particular topic to be very well on the table. So that's what you are learning now: study design and sampling in public health. So we will go deep into it, and I need you to understand what study design is, and then we will now talk about sampling, how it is done, because if you don't get this, you cannot be a good researcher. Now, what is the objective? Now we'll be looking at it first with the questions. What are the key considerations when designing a study in public health? We want to design a study because next year, or probably 2 years' time, or this year, you probably will be carrying out your research project. And your research project is very key. It is the culmination of your program. And you will need to understand what is, study design. So that for that study you have chosen to do, you have gotten your topic, you should know how to go about the designing and what sample that you'll be needing. Now we will go further to see study designs as an overview. We are going to see cross-sectional studies, cohort study design, and case control study design. We will now see sampling techniques and their importance in health studies. We will go further to see sample size calculation for different study designs. So let's dive into it proper. Now, key considerations in designing a study in public health. Key consideration in designing a study in public health. Number one is research objective. You have to define the problem or the health issue that you want to address. Of course, you just don't hit the road and begin to share questionnaires. No, you don't just begin to write about a research without first of all defining what problem do I want to look into. Is it malaria? Is it tuberculosis? Is it weakness, mental issue? Is it diabetes? Or is it that how will I put it now? The use of ChatGPT among students? Is it technology? Which area do you want to look into? There must have been a problem. That problem has pushed you into wanting to see what you can do as a way of adding to the body of knowledge, to examine, to find out conclusively, scientifically, that this is the problem. This is what is causing it, and this is what you found out when you checked, and compared to other papers, this is what you have as an outcome. You need to be clear on the outcome you aim to measure. For example, disease prevalence. How prevalent is this problem? Risk factors. What are the causes, leading factors, primary or secondary, that is causing this problem? Number two, study design selection. Study design selection. You need to choose a design that aligns with the research question. You need to choose a design that aligns with the research question. It could be cross-sectional, it could be cohort, or case control. Later on, we will look at the differences between the three. You need to consider the flexibility of this study? Is it possible? Can it be done within the framework of time? Ethical implications, will it not cause trouble? Will somebody's right not be infringed? How can you go about it? And resources available, do you have enough resources to be able to cater for that research project? If you don't have it, then you don't proceed with it. Number 3, ethical considerations. Ethical considerations. Here we want to ensure that the study design protects the participants' rights. The rights of the participant will not be violated because you want to carry out a research. You need to obtain ethical approval, maintain confidentiality, and ensure informed consent. That the information I give to you as a respondent, I will not go and find it somewhere else in the public, and the paper is on the ground where they sell akara, and then I see my name, I see history of my health, because I gave it to you when you were trying to do your research. I was free with you, believing that you will protect the information, because you asked me for my age, you asked me for where I live, you asked me for my health issues, and I'm open to you. I let you have all these details. You must assure me ethically that you will protect me. You protect all the informations that I've given to you and not allow any of them to be found in the public unprotected, unguarded tomorrow. And this is important. That's why you have to take people's consent to say, okay, I'm willing to take part. And if I'm not willing to take part, you are not going to coerce me. You will let me go, because it's my choice to be part of that research as a respondent or not. Number 4, data collection method. Data collection method. Here you select the appropriate tools and methods. Is it that you want to do survey? Remember I told you about survey when we are talking about demography. Here we want to talk about data collection method, and you need different tools or method to be able to collect your data. Survey is there, clinical data is there, laboratory test results are there, and there are so many. Remember, vital statistics are also there. Here you ensure the reliability, the trust, confidence in those data, the validity of those data. Be sure that those data can be used. Number 5, bias control. Bias control. Here you plan strategies to minimize bias. Example, randomization. You don't just pick because I know this person, come and take part in this research. Oh, it's my teacher. Oh, it's my friend. We are best friends, so come and be part of this research. No, there must be clear ways of minimizing bias. For example, randomization. I get to a class and there are 36 and I need only 15 persons to fill this form. I do not say, okay, you come, you are my friend, class rep, you come. No, you don't do that. What you simply do is you carry out methods, including randomization, where you decide that, okay, let everybody be in a sitting arrangement without knowing who is there. We are taking the first 2 persons in the first seat. We will count 2 seats. We'll take from the 4th seat. We'll count 2 seats. We'll take from the 7th seat. 2, 2, 2, 2, like that. Randomization, without having to know whoever. Blindly, you just do that, and whoever is found there is picked. It could be stratified. Okay, we will take it this way. Everybody in that class, let's check their age. Those who are between 12 to 14, we'll pick 6. From 15 to 17, we'll pick another 6. From on and on like that. You see, that's another stratified level. That's another randomized level. Blinding, that's another method. Without knowing, okay, no problem. We'll do a kind of ballot, and anybody that picks yes is part of this study. If you pick no, you are not part of it. Ensuring representative sample is very key when you want to avoid biasness in your research. Time frame. You need to determine how long the study will run, as this affects data collection, analysis, and interpretation. If you stay too long, it becomes a challenge. You run out of resources, and probably you don't have those patients again, because they will be discharged and they would have gone home. So it's important that you deal with your time frame. Very, very, very important. Let's now move to the next one, which is overview of study design. Now let's see cross-sectional study. Straight to the point. Like I told you, I'm not going to bore you. I want you to enjoy this course. Now, cross-sectional study. We are seeing the overview of study designs now that we use in public health. Cross-sectional study. Why do we use cross-sectional study? It's to measure the prevalence of a condition or behavior at a single point in time. Oh, this condition has been there for a long time. Let's see how often has it been occurring. How persistent has it been, this particular condition? Or we want to see the behavior of a particular population at a single point in time. We gather them, we ask information, get the information, and that's it. We'll go and carry out the analysis. We are not doing it today. We come back tomorrow, the same set of people. We come back next tomorrow. No. We come, we gather them, same set of people in that population, get the data, go and analyze the data. What is the strength of using cross-sectional study? It is quick. It is cost-effective for descriptive analysis, where you just get information about the population and then you check the mean, median, mode, and you can tell, okay, this is highly prevalent, this is less prevalent, this is not even there at all, and so on. But it has its own limitation. It has its own limitation. One major limitation that it has is that it cannot establish cause and effect relationship. It only provides you a snapshot of what is happening on ground, but it can't tell you what is causing it. It can't tell you, the effect of that thing, that challenge on the people. It can't tell you that. It can't. So you need to proceed to higher level of study designs if you now want to know what is causing that problem and how is that problem affecting the people. What damage is it causing? And so it can be applied by assessing the burden of disease in a population. Example, the prevalence of hypertension in a community. What's happening? Everybody in this community, when they come to the clinic, they all have features of high level of hypertension. So all these things we want to check, and we want to be sure that we could nip it on the board. Let's see the next one, which is cohort study. Cohort study. Why do we do cohort study? Because it follows a group of people over time to assess risk factors for disease development. For example, smokers. They've been smoking over the time. They came to the hospital and we decided to do a research. From the day they came, maybe in 2010, they enrolled them and then they are asked to come for laboratory checks or clinical checks free of charge every 6 months or 3 months. That way you follow those set of group of people over time, 1 year, 2 years, 3 years, 4 years, to see the effect of smoking in them. You may not let them know, but you let them know that you want to carry out the research, this, that, and that. But you want to find out this thing, this habit, what could it cause? What problem could it, bring? And you want to find out in terms of the disease development. Number 2, it has a very good strength. It can identify the cause and the effect relationships and the timing of events. You see that over the time, we know when this person came, we know what the condition was in 2010. 2011, we know when it began to become worse. We know when the person is now almost close to terminal death and all that. You can tell the effect of the lungs when the liver started coming down, when the bowel cancer now came in. You can tell when all these, effect and causes now came in. And it's very important that you take note about all these things. Secondly, also, we'll be looking at the limitations. We'll be seeing the limitations. Now, one of the problem of the limitation is that it is expensive. Very, very expensive. It is really expensive because imagine a research that you'll be doing over the time. As you are doing this research over the time, you are spending money, you are following them up, you are taking care of them. And remember, we are paying for this treatment and those laboratory tests. And so it is expensive, it is time consuming, and there could be loss to follow up. And this loss to follow up can bring biased results. For example, 3 die along the corner, whereas we are supposed to follow them up for 10 years. But before the 10 years, out of 20 patients, maybe 4 died. Out of 100 patients, maybe some just traveled. We didn't hear about them again. We lost some patients. We didn't even know when we lost them. We just didn't see them in the hospital again. Their phone wasn't going again. Of course, when people die, families switch off the phone and they, keep it. Except you have to travel. And maybe you got there, you see that it's no longer living there. The children has left there, maybe after the demise of that respondent. And so there could be laws to follow up. Application now. Investigating risk factors for chronic diseases like smoking and lung cancer. It is very useful. You use it to investigate the risk factor, the causes of that chronic disease like smoking and lung cancer. The next one we are going to see is the case control study. The case control study. That's the next one we want to talk about. Under the case control study, we will see the purpose and the strength. And there's something spectacular about the case control study. The case control study compares individuals with a disease, that is, cases, to those without the disease, in order to identify the risk factors. So let me give you an example. Now, we want to carry out an experiment or a research that has to do with exposure to a particular disease, and those who have the ailment, we will take blood samples from them and we will check some parameters of diseases, and then we will also look for those who are not sick at all, that do not have the problem, they don't have that particular issue. We will now take blood samples from them and we will compare between those who have and those who don't have. That way we can see starkly, we can see clearly the results in those who have, by the time we compare with those who don't have, because you have what we call the reference value, the normal range and the abnormal range. Now, in terms of strength, case control study is good for studying very rare diseases and outcomes. It's relatively quick and it's inexpensive. The limitation, although, is that recall bias and difficulty in establishing temporality. It's part of the limitations. There is usually the recall bias and difficulty in establishing temporality. You can't tell whether this is just temporal or it is casual, or maybe because the person didn't sleep well, he has a symptom of malaria, or probably the person took a drug some few months ago, maybe 2 or 3 months, which is causing that issue that will soon relapse, and you think this person has that problem. In terms of application, case control study helps in the examining of association between environmental exposures and disease outcome. For example, lung cancer and asbestos exposure. So you expose this group of animals to asbestos and see they will come down with lung cancer, and then you have these other animals they eat but they are not exposed to asbestos, and at the end we harvest their lungs to check the cell tissue. We take blood sample from the 2 sets of animals to see the impact. That way you see the impact or the effect of asbestos exposure. Now let us see sampling techniques in health status. Sampling techniques in health studies. Sampling techniques in health studies. I told you, based on the study design, you will need different sampling techniques. Different sampling techniques. And this is very, very, very key. You have the random sampling technique. Random sampling technique, where every individual in the population has an equal chance of being selected, and this reduces bias and ensures equal representativeness. So you can pick anybody, because as a matter of fact, anybody you pick randomly within that population can suffice. Number 2, you have the stratified sampling. Population divided into subgroups, that's strata, age wise, height wise, weight wise, size wise, but they are all the same population, but we divide them into subgroups based on characteristics like age, sex, disease status. Samples are randomly selected from each subgroup. Now, after you have divided it into subgroup, we now take samples from each of those groups. Now, if you do that, it is stratified sampling. Number 3, systematic sampling, where every nth individual, that's every numbered individual or that position individual, is selected from a list suitable for large population, but may introduce bias if there is a hidden pattern. For example, now I come into a classroom and I want to carry out systematic sampling, and I say, okay, there are 30 and I want to take only 15, and I decide to say, I want to take only 10. I decide to say, okay, randomly I make up my mind that I will arrange all of them in no particular order in a straight line, and they do that in the classroom without me being there, and I make up my mind that when I get there I will take number one, and after the two persons after number one I will take number two, after three persons I will take number three, after four persons I will take number four, after five persons I will take number six, on and on. That's systematic sampling. So that nth number after those criteria will be selected. You understand that? So you have to be careful not to introduce bias. You don't need to know them. You do the arrangement in such a way that you couldn't have manipulated it. Number four, cluster sampling. Population divided into clusters. Example, geographical areas. This geographical area is one set of population. This geographical area is another set of population. And then random samples of clusters are selected. So you now look at this cluster, there are 13. This group of people, for example, you go into a market, engineers, the market pepper sellers, vegetable sellers, meat sellers, egusi sellers, those who sell one thing or the other. Now we want to do a kind of research in that market, but there are different set of people selling different things there, so that we can touch everywhere. We first put the clusters there, those selling the different things I've talked about. Then we now do a random selection among that group of persons. So we go into those selling meat, and when we get into those selling meat, we check them and we say, okay, those of you selling meat, I want to now pick 4 persons, and we pick random 4 from among them. Random 4 from among them. Secondly, we go into the next one, and we pick another random 4 from among them. So those selling meat, they are about 14. We pick only 4 randomly. You can put 14 papers in your hand, only 4 is yes, and you say, well, I don't want to know who is who. Anybody that we pick, so everybody pick. If you pick yes, you are part of this, and if the person accepts, gives you his consent, then he fills your form, and then he takes part in the research. That's it. Now number 5 is convenience sampling, selecting individuals who are easiest to reach. While it is cost effective, it can introduce significant bias. For example, you have to go to a particular place, and in that place you can't tell who and who will be there. In fact, you cannot tell if you will meet anybody. However, people come, and it's people who are there that you need for this research. And so you make up your mind that, okay, because there are times you go there, you don't meet anybody, you go back home. There are times you go there, only 3 people will come, and so you can't go there and begin to select. No, any individual that shows up, because they may not show up tomorrow, you pick. So you select individuals who are easiest to reach. They are available, you select them, they give you their consent, because it is cost effective. You may come tomorrow, you won't meet anybody. You may come next week, you won't meet anybody. But once you meet anybody at a particular time, you co-opt them into the research with their consent, and then you go on. But be careful so that it does not introduce bias. So these are the sampling techniques in health studies. Now let us see the sample size calculation for different study designs. The sample size calculations for different study designs. When you say sample size calculation for different study design, it really reflects the importance of size calculation. For example, I want to carry out a research in your university environment. I want to find out the level of cognitive behavior, using impact of ChatGPT on cognitive behavior of students. Now, you don't expect me to now do a research for all the students in the university. That would be a very clear task. But before I would start, first of all, I will have to determine the sample size, or the power for this study, the power size for this study, the precision of the estimate, and the ability to detect a meaningful difference or association. Because if I do not calculate, if I do not check for the sample size, I will have a problem being able to detect what minimum level of participant will I need for this result to have value, for this result to be able to give me a tangible outcome. Very important. I need to know this value. If I fail to know this value, then there would be a problem. So what do I do? What then do I do? I will now carry out a sample size calculation. Now you have the total sampling, where everybody is used in a situation where they are just 40. Everybody in that place is 40. We just use everybody. We don't need to start saying, okay, we want to use a subsect among the sect. No, just use everybody. That's a total sampling. But the total sampling here now for everybody is 6,200. We can't do his research for that. It will be too expensive, too equivalent, too tough. So what do? We now calculate. And how do you calculate? You know the total population, and based on the total population, you check out for one, your confidence level, where you need a 95% confidence level to be able to say, okay, this is the true value that I intend to use within this calculated range. So 95% confidence level, you want to see the power of the study. Okay, typically set a 80%, which indicates an 80% chance of detecting a true effect. Or you look and say, okay, this whole population, if I can use 50%, it will be okay instead of 100%. Or if I can use 30%, it will be okay instead of the 100%. You can also now say, okay, if I'm going to use 30%, how will I now break it down? Okay, this is university. Then we look at the total department. From the department, we decide how many numbers of students do we have in each department. There we can now decide, all right, we are now taking from each department maybe 35% from each department. Now you calculate that using the Cochrane, and you use any statistical tool for power size calculation. Now you see the population variability. More variability in the population requires a larger sample size. So if the differences between each sect seem to be very wide, you need to incorporate those areas. For example, they are all boys, no big deal. But you have boys and girls. Well, you need more now. You now have boys, girls, and probably another sect. You know what I mean? This hidden population. We need to get them too. So the more you have variability in that population, then you need more set to be able to equally represent every one of them. So those are the factors that affect sample size. Let's now see how do we calculate it. Calculations for different designs. For cohort studies, you can use statistical formulas or software to calculate sample size, but you consider expected incidence rate in the exposed and unexposed group. We just go to a past research and see the prevalence rate, the exposure rate. You see them upon which they used to calculate their sample size. But all you need to do is just understand that you can use statistical formulas or software to calculate sample size. For case control studies, typically the sample size is calculated based on expected odd ratios, control to ease ratios and to case ratios, and to the level of statistical power design. You still use statistical tool to calculate the power size. For cross-sectional studies, sample size calculations have to focus on estimating proportions, considering the expected prevalence of the condition. So it's very important that you know how to calculate your power size before you start. You need to know the minimum amount of population that you need for that your study. Let's say application in public health. What is the application in public health? Of course, it is important in monitoring disease burden. Cross-sectional studies are used to determine the prevalence of infection diseases or the risk factors in that population, helping policymakers to be able to plan the interventions that are needed. Number two, we need it to be able to evaluate public health interventions. With the cohort studies, it is helpful because we will now be able to assess the long-term impact of that disease on the public health programs. We now know, okay, we need vaccination campaigns. We've seen the effect of this drug. We've seen the effect of malaria. We've seen the effect of smoking over a long time. And so we can now tell what interventions that we can bring in to be able to curb the impact of that challenge. Number three is that we can identify risk factors. We can identify risk factors. So there's case control studies that allow researchers to identify factors contributing to diseases. guiding public health prevention strategies. So this way, for example, you are linking air pollution to respiratory diseases. So you can now use, a control and a population that is exposed to the disease. You can compare them and you can see the impact of the exposure. Now, you can also see the resource allocation. That's one of the benefits. By calculating the sample size and choosing the right design, public health officials can maximize the effectiveness of their research while staying within the budget and time control. So you can know, okay, this budget will finish at so time. This is what I need because I'm doing it for only 2 months or 3 months. This is the specific number of people I'm meeting, and so I can meet them within so and so time. You can stay within budget because you'll be transporting yourself. You'll be going to that population, that community, to be able to get the data. So we have come to an end of this course. I want to thank you so much for joining me on this course, and please remember that if you have questions to ask, you can simply do that by writing them on your Google Classroom. We're always there to receive your questions and to answer them. Remember at all costs, it is your duty to study. It is your duty to take notes. It is your duty to ask questions. It is my duty to come around, answer all your questions, provide clarity to anywhere that there's confusion. And I tell you the truth, you will do well in this course, you will enjoy this course, and before you know, you're a very good biostatistician. Oh yes, and you'll be applying it in the field. When you get out there after you've graduated, you remember all these things you've learned. You can put them to practice, and you will see that when you face interview board and you are asked these questions, you can provide answers with clarity, because as my student, you are bound to be successful. I thank you very much for attending this class, and please remember, pause when you need to pause, write when you need to write, and make sure you understand. And if you don't, I'm always available. Meet me at the Google Classroom, meet me and ask me questions. I'll be there to attend to your questions. I'll see you in the next class, where we'll be discussing about the process of research design. Thank you and have a blessed day.